In this tutorial, we are going to look at circle theorems, and then we are going to prove some of the theorems and then also solve complex problems on circle theorems. The video is going to be in two sessions. The first session, we are going to talk about circle theorems and then we are going to prove them. In the second session, we are going to solve the problems on circle theorems. With this in mind, what then is a circle? A circle is a closed two-dimensional shape where every point on the circle is equidistant from a fixed central point. So this fixed point is the center. Now, if you look at the point here, the distance from this point to this center is the same as the distance from this point to this point on the circumference. And this is what we call a circle. Now, the radius is just the distance between any point on the circumference of the circle to the center. Now, the diameter passes through the center and touches the two ends of the circle. It also divides the circle into two equal parts. This is one part and this is another part. In this case, we are going to call each part a semicircle. That is half of a circle. Now, the circumference is just the outline of the circle. Now, if a line touches 2 points on the circumference and does not pass through the center, then that is a chord. A chord. Now, we are going to look at what we call a tangent. A tangent touches the circumference of the circle and makes an angle of 90 degrees to the radius. Now, if we have a chord, then we have an arc. So this is a chord and this is an arc. The next thing we are going to talk about is a sector. A sector could be a major or a minor, just like a segment. Now, a sector is defined by a radii and an arc. So if we have these radius and we have these radius and there is an arc, then we have a sector. So this small portion is going to be a minor sector and this bigger portion is going to be a major sector. So that is a major sector and this is the minor sector. We're also going to look at what we call a segment. Now, a segment is just defined by a chord and an arc. So let's look at this chord. If we have this chord and then this arc, then we are going to have what? A segment. This is a major segment and this is a minor segment. Alright? Now we are going to talk about some of the circle facts. These facts state that any triangle AOB with A and B on the circumference and O at the center of a circle is isosceles. Now what we are saying is that anytime you have a triangle, that is triangle AOB, with A and B on the circumference. So we have A here and we have B here. and we have O at the center, then it is isosceles triangle. We are going to explain. This is the reason. From this point to this point becomes a radius, right? Also, from this point to this point also becomes a radius. Now, if this is a radius and this is also a radius, then they are the same, right? And in isosceles triangle, two sides are the same, right? And so therefore, this becomes an isosceles triangle. Now, if it is an isosceles triangle, then the angles formed at the base must be the same. So this angle is going to be A, and this angle is also going to be A. If this is A and this is A, then A plus A plus this angle should be 180 degrees. So we are going to subtract A and then another A from 180 to give us this portion of the angle. And so 180 minus 2A is going to give us this portion. This fact also states that the tangent to a circle is perpendicular to the radius at the point of contact. What we are saying that if you have a straight line that touches the circumference of a circle at a point, let's say P, to say that this line is a tangent, then it implies that this line is perpendicular to the radius at this point of what? Contact. Hence, the angle formed here is going to be 90 degrees. Fact number 3, two tangents. If you have two tangents, tangent 1, another tangent, tangent 2, then the triangle produced by two crossing tangents is isosceles. If you are to draw a straight line, or which is a chord, then you are going to say that this line is the same as this line. Then it forms what? An isosceles triangle, right? Because two of the sides are the same. The fourth fact is that if a radius bisects a chord, it does so at right angles. And if a radius cuts a chord at right angles, it bisects it. What we are saying is that if we have a circle and we have a chord, let's say AB, and then we have a radius that divides this chord into two equal parts. From here to here is the same as from here to here, denoted by these signs. Then it does so at right angle in the sense that the angle between the radius and the chord is 90 degrees. Alright? So that is it. Now we are going to begin with the circle theorem. The first theorem we are going to talk about is the theorem of the double angle. Now, the angle subtended by an arc at the center of a circle is twice the angle subtended at the circumference. What we are saying is that if you have an arc AB, right, and this arc subtends an angle at the center, this is the center, and the same arc subtends an angle at the circumference of the circle, that is it, then this angle is half of this angle. So if this is 100, then this is going to be what? Half of 100. And if this is 50, then this is going to be 2 times of what? 50, which is 100. If this is x, then this is going to be what? 2x, which is 2 times what? X. Now, we're also going to talk about the theorem of a semicircle. The angle in a semicircle is a right angle. So if you have a circle and we have a diameter that divides the circle into two equal parts. Now, if this diameter subtends an angle at the circumference of the circle, then that angle formed is 90 degrees. That is what this theorem states. Now the next theorem is the segment angles theorem. Angles in the same segment are equal. So if you look at these, we have an arc AB, and this same arc subtends an angle in the same segment as that of this. And so if this angle is 30 degrees, then this angle is also going to be what? The same 30 degrees. We're also going to talk about the cyclic quadrilateral theorem. Now, a quadrilateral is a four-sided figure. So if we have a circle and we have a quadrilateral in it, that is a four-sided figure in it, then we are going to consider this theorem, which states that the sum of the opposite angles of a cyclic quadrilateral is 180 degrees. So what this is saying is that if we have this quadrilateral in a circle, then if we have this opposite angle, it must be 180 degrees. 70 plus 110 should be 180 degrees. And 100 plus 80 should be 180 degrees. So if we have A and then we have B here, then A plus B must give us 180 degrees. And so this is how we are going to be applying these kind of theorems. The next one we are going to talk about is the theorem of what? Alternate segment. Now, if you have a circle and then we have a tangent and we have a chord, let's say AB, and this chord subtends an angle at the circumference, let's say it is 75 degrees, then we are saying that this 75 degrees is the same as the angle between the chord and the tangent. Now we are going to be proving the theorems. We start with a double angle, which states that the angle subtended by an arc at the center of a circle is twice the angle subtended at the circumference. So if you have this arc that subtends at the center and it is 100 degrees, and the same arc subtends at the circumference, then it is going to be what? Half of 100, which is 50 degrees. And so we are going to prove this. So now, let's take this circle. This is an arc and it subtends at the center and subtends at the circumference. Remember, from here to here is a radius, and from here to here is also a radius. Now, I'm going to draw another radius from here to here, right? So that is what I have now. Now, I'm going to call this part to be A. If this is A, then this is also going to be A. Why? If you are to consider this triangle, this is a radius and this is also radius. And so it is an isosceles triangle and the angle formed at the bases must be the same. So if this is A, then this is also A. I'm going to call this side B. If this is B, then this side is also going to be B, because this is also a radius and this is a radius. So this is also going to be B. The sum of interior angles of a triangle is 180 degrees. So if we add A plus this angle here, it sum up to what? 180 degrees if we are to consider this triangle. So how do we obtain this portion? It's just going to be what? 180 minus A minus A. In that case, it becomes 2A. So 180 minus 2A. How do you obtain this? This is also going to be what? 180 minus 2B. Right? Now this is a fixed point, which is the center. Angles about a fixed point sum up to what? 360 degrees. So if we know the expression for this angle, and we also know the expression of this angle, then if we subtract these two angles from 360, then we are going to obtain the expression for this angle. So first of all, let's add these two angles. If we add 180 to what? 180, it becomes 360. Negative 2b minus 2a is going to be what? Negative 2b, negative 2a. So I'm going to have 360 minus what? Negative 2a, negative 2b. Keep it in mind. Sorry, I cannot write. That is why I'm not writing. So you have that. We have 360 minus 2a minus 2b, right? Now we said we are going to subtract this from 360. So 360 minus 360 becomes what? 0, right? Then the minus is going to affect the negative 2b and the negative 2a, right? So this becomes what? Positive 2a plus 2b. Remember that we said that if this is a chord and it subtends at the center and also subtends at the circumference of the circle, then the angle formed here should be 2 times the angle formed here, right? So look at something. We have B and A. If we add A and B, we are going to have A plus B, right? Do you get it? A plus B. Now, to obtain this angle, what is it going to be? It's going to be what? 2 times A plus what? B. Now, 2 times A plus B is just 2A plus 2B. So having this, we have proved that what? Anytime we have an arc and it subtends at the center and also subtends at the circumference of the circle, then the angle formed at the circumference of the circle is half the angle formed at the center of the circle. Now we are going to prove the theorem of what? A semicircle. We state that the angle in a semicircle is a right angle. Now we have a circle and we have a diameter that divides the circle into two parts. That becomes a semicircle, right? Now the diameter subtends an angle at the circumference, and we are saying that this angle subtended must be 90 degrees. And so we are going to prove it. Now, remember, from here to here is a radius. From here to here is also a radius. Now, we are going to draw another line from here to this point. And this also becomes a radius, right? Now, if I call this point A, the angle formed here, A, since this is a radius and this is also a radius, then the angle from here is also going to be what? A, right? Now if I call this side to be B, then since this is a radius and also this is a radius, then the angle from here is also going to be what? B, right? Now the angle from here is going to be what? 180 minus 2a, just like we did for the other proofs. And this is also going to be 180 minus 2b, right? Now, if you are to consider this bigger triangle, the sum of the interior angles of a triangle sum up to what? 180 degrees. So A plus B plus B must be equal to 180 degrees. Now A plus A is 2A, right? B plus B is what? 2B. So we have 2A plus 2B should be equal to 180 degrees. So if we factorize 2 out, then we are going to have 2A plus B, right? To be equal to what? 180 degrees. And if we expand, we are going to have 2A plus 2B is equal to 180 degrees, right? Now, if we divide 180 by what? 2, and this side also by 2, we are going to have 90 degrees equals A plus B. So now where is A plus B? A plus B is here and it is 90 degrees. And so we have proved it. Now you're also going to prove the segment angles theorem. So we have a circle and we have an arc that subtends an angle at this point and also at this point. That is in the same segment. If this same arc subtends at the center, if this is A, then this is going to be what? 2A, right? Now, if this is 2A and the same arc subtends at this side, then it's going to be what? Half of what? 2A, and that is also what? A. Hence, we have proved. Now, we're also going to prove the cyclic quadrilateral theorem, which states that the sum of the opposite angles of a cyclic quadrilateral is 180 degrees. That is, if we add 70 to 110 must be 180. Then if we add 80 to what? 100 must be 180. So we have a circle and we have a quadrilateral in it. Now, we want to say that this chord subtends an angle at the center and subtends at the what? Circumference. The same chord subtends what? An angle at the center in this side and subtends at the circumference at this side. If this side is A and this side is B, then the angle subtended here is going to be 2A. This chord subtends at what? The center and subtends at the what? Circumference. So if this is A, this is going to be what? 2A. The same chord subtends at the center and subtends at the what? B. So if this is B, this is also going to be what? 2B. Now this is a fixed point. Angles about a fixed point sum up to what? 360 degrees. So 2A plus 2B equals 360 degrees. Now, if we factorize 2 out, we are going to have 2 times A plus B equals 360 degrees. Now, if we divide by 2, we are going to have A plus B equals 180 degrees. So if we add A plus B, it must give us 180 degrees. Hence, we have proved that the opposite angles of a quadrilateral in a circle sum up to what? 180 degrees. The next one is the alternate segment theorem, which states that the angle between a chord and a tangent at the point of the contact is equal to the angle in the alternate segment. And so this is the assignment for you. Go and find out how to prove this. So guys, we are going to end the first session here. And in the second session, we are going to solve problems on circle theorems. Stay tuned. Please consider subscribing, like, share, and comment. Thank you.